Welcome to clickmyproject.com. We discuss about extended coding and pooling in the HMAX model. In this paper, our proposed method allows for the manipulations of two crucial variables for image classifications, discriminability and invariance. Our filters are modulated and trained to optimally fit local image structures, and as a result, generate a good balance between the discriminative representations and invariance. In particular, our result on the three natural image set and one synthetic image set highlight the increase in discriminative power of our network, as well as its robustness to local geometric transformations. Moreover, spatial recognition of local feature into a global representation is a key aspect to image recognition. In these regards, the multi-resolution pooling introduced in this paper provide rich spatial information, resulting in improved classification scores. Now we described about the system architectures. The system architecture considered for pre-processing, HL filters, SVM classifications and retrievals. The input image is given into the pre-processing technique. The pre-processing technique is used for removing the unnecessary of the noise. Images can be eliminated, and unnecessary noise refers to unwanted pixels in the frames. Pre-processing method use a small neighborhood of a pixel in an input image to get a new brightness value in an output image. Such a pre-processing operation is also called as filtration. The pre-processing output is given to the HL filter. The HL filter, it can be reducing the noise. The output is given to the classifications of the SVM. The classifications by SVM, it can be used for all the cells into two disjoint group of cells. This grouping is then used to train a SVM classifier in the root nodes of the decision tree, using the samples of the first groups as positive example and the samples of the second group as a negative examples. These classes from the first clustering group are being assigned to the first left of the subtree, while the class of the second clustering group are being assigned to the right second of the subtree. The process continues recursively until there is only one class per group, which defines a leaf in the decision tree. The classifications output can be given into the retrieval. It is a equidistance distance which can be calculated. The output will be shown. The relevant images are retrieval using equidistance distance will be output will be displayed. We see about the output of the window. First we click the menu run position. The creating dictionary by sampling from training images will be opens. Test image, we can selecting the various of image. I selected for 4th images. The output will be displayed. This is the pre-processing technique. In this processing techniques, noise images can be eliminated. The original brightness of the images will be displayed. We can see about the original brightness of the images will be displayed. These images will be shown. This is the classifications of the image. We can be classifying the several images in the grouping. Is then used to train as an SVM classifier in the root node of the decision tree, using the sample of the first group or as a positive example and the sample of the second group as a negative examples. The classes from the first clustering group are beginning assigned to the first left subtree, while the classes of second clustering groups are beginning associated with the right second group of subtree. The process continuously recursively until there is only one classes per group while define the leaf in decision tree. The retrieval images are retrieval using can we use it to detecting the images of the particular distance. The explicit distance will be calculated. The x and positions value and y and position value related pixel images will display the distance will be calculated. Finally, we conclude that we present an investigations into local invariant feature for overhead image retrieval. The first such a study of its kind, we demonstrate that local invariant features are more effective than the standard features, such as class and texture for image retrieval of LULC classes in high resolution aerial imagery. We will quantitatively analyze the effect of a number of design parameters on a BOVW representations, including saliency, grid-based feature extractions, the size of the visual code book, the clustering algorithm used to create the code book, and the discriminative measure used to compare the BOVW representations. Thank you.